Okay, question number 13 from the Pearson's Edexcel IAL new textbook P1, chapter review 7, which is radians, page 147, question number 13. Okay, we're told about two circles, C1 and C2, both of radius 12 centimeters. They have centers O1 and O2 respectively. O1 lies on the circumference of C2, O2 lies on the circumference of C1. The circles intersect at A and B and enclose the region R. Okay, so let's make a little drawing first. Okay, so let me just put one center circle there. And if you wanted to make your sketch with the compass in the exam, it's perfectly fine. I'm using this tool here. So it says basically the centers O1 and O2. O1 lies on the circumference of C2. Okay, so that's, let me just do this so that I can group it together. They'll move together, hopefully. Okay, so that's the center of that circle and that circle. So now I'm going to clone this, not clone it, I'm going to copy this circle. Okay, I'll copy and paste. So it'll be exactly the same size. Copy and paste. Okay, so now those two circles are exactly the same size. And hopefully they'll move together. Okay, so it says the center of one of them lies on, okay, I can just fill it from here. So basically the center of one of the circles, okay, lies on the circumference of one, and the center of the other lies on the circumference of the other. That's what they're saying. So this is circle C1, and this is the center of C1. This is the circle C2, and this is the center of circle. So this is, sorry, what am I talking about? That's C1. Okay. This is the circle C1. Okay. And it's, and this is the center of C1. This is the center of C2. Okay, so the center of C1 lies on, the center of C1 lies on the circumference of C2, and the center of C2 lies on the circumference of C1. Okay, that's what that's showing. So as the circles intersect at A and B. So let's call this A, and let's call this B, and enclose the region R. So this is the region R. Okay, you can make it a bit shaded if you wanted to. Oops, a bit too thick there. Okay, change the color. Okay, so this is the region R, which is enclosed, okay, by that description there. And then it says, okay, show that angle AO1B equals 2 pi over 3. So AO1B would be AO1B. Okay, that would be the angle in this position over here. That would be the angle in this position right here. Okay, let's call that theta for now. That's the angle theta. So AO1B. Now, we know the radius of these circles are both 12 centimeters. Okay, and so if I want to find this angle, let's have a look. We've got the length from A to B. Well, we don't have that length, but we can form a triangle from that. I know that this is 12 centimeters, and this is also 12 centimeters. These two are both 12, okay? And I need to find this angle. Alright, now, can I find this length? That's what I need to know. Okay, this is the chord from A to B. Let's see, that angle is the same as that angle. They'll be the same. and that's 12 centimeters. Okay, show that angle AOB is equal to 2 pi over 3. Okay, so now 12 and 12 and R. Okay, what I also know is something else. This is something else I can do. If I join O1 and O2 together, okay, this is the key for this question. Sometimes you need to just sit back and think a bit. Okay, well, basically, the key to the question here right now, if I join O1 and O2 together, I know that that length is 12 centimeters. Okay, that length is 12 centimeters because it's from the center of the circle to its circumference. Okay, so that whole length from O1, the length from O1 to O2, the length O1, O2 is equal to 12 centimeters. Okay, let me call this point here the point P. Okay, so what we've got here is like a triangle. Let me just draw half of it for now. Okay, we got this triangle where this is A and this is O1 and this is O2, and this length is 12 and this length is exactly the same as that length, and the whole thing is 12, so this part must be 6. Okay, so here we have a length that's 6. Okay, I can work out what this angle is. Let me call the angle X now. Theta is the angle all the way across, that's what we have to find. This is a half of that angle, okay? So we can see this is a right angle because we've dropped a perpendicular from the vertex to the base of an isosceles triangle. So we can say that the cosine of X is equal to 6 over 12. Okay, so the cosine of X is equal to a half. So we know that X is equal to, well, shift cosine of a half. Okay, we're going to talk about radians here, okay, because this is radians. That's going to be, the shift cosine of a half is going to be 60 degrees. 60 degrees is pi over 3. Therefore, the angle theta, what we're looking for is 2 times X, because it's twice the angle there. We found that angle is pi over 3. So it's 2 times pi over 3. So the angle A01B is going to be 2 pi over 3. We've just shown that, okay? I hope that's clear. Then it says, hence write down in terms of pi the perimeter of R. So now we've got to write down the perimeter of this whole arc. So what we could do is we can see that it's made up of this arc of this particular sector. So like, for example, if we have I'll just draw it by pen. We have like this arc, that's like A, that's like B, and that's like O1. And we got this arc, that's like O2, right? So if we find the length of one of these arcs and multiply it by 2, we found the length of the whole perimeter of this shape that's enclosed by R, or that encloses R. So basically, let's look at one of those arcs. It could be anyone. I'm taking O2 and A and B, and this is O1, and this is 12, and this angle is 2 pi over 3. So the length of an arc is equal to R times theta. This is part B now. The length of an arc is R theta. So the length of the arc is 12 times 2 pi over 3, which is going to give you 8 pi. That's a 4, 1, 8 pi. Okay, therefore the answer to the question, okay, the perimeter of R, okay, so the perimeter is going to be 2 times 8 pi, which is 16 pi. 16 pi centimeters. Okay, so there we have the answer to part B. It's the length of this arc plus the length of that arc One of them, its length is r times theta, r times 2 pi over 3, which gives you 8 pi. We have 2 of those, so that's 16 pi. Alright, part C says find the area of R giving you answer to 3SF. So the area of R is going to be the area of one of those segments times 2. Yeah, you take one of those segments and multiply it by 2. So I need to just think about the area of this segment here and multiply it by 2. Okay, so the area is going to be 2 times, okay, and we have a half r squared. Okay, so there's 2 of these segments, so this is for one of them, a half times r squared times the angle. That's going to be the area of the whole of this sector, minus the sine of the angle, and this must be in radians. Okay, take away the sine of, take away the area of the triangle, you're left with the area of the segment. And I've got 2 of them, I've got this side and that side. They're both identical. So let me just put all those values in. Now the 2 and the half will cancel out. Okay, so you're left with r squared, which is 12 squared, times, the angle was 2 pi over 3, minus the sine of 2 pi over 3. Okay, so you're going to have 144 times 2 pi over 3 minus the sine of 2 pi over 3 is the same as the sine of pi over 3, which is root 3 over 2. But they want the answer to 3SF. So I could just take this as it is, alright, and I could just basically make sure my calculator is in radian mode, which it is, because we need to use radians and with sine here, and I can say that's 12 squared, which is 144, times, okay, 2 pi over 3 minus, minus the sine of 2 pi divided by 3, close the bracket for the angle, and close the bracket for the whole thing. Okay, and that should give me my answer, which is 176.885. So that gives me 176.885. Now they want the answer to 3 significant figures. That gives me 17177 centimeters squared. And there we have answered that question as well.